Alright guys, we're back and we're looking at one of the questions that was posted in yesterday's class where we're asked to sketch the graph of y equals minus 5x plus 1. So we're actually going to approach this question two ways. I'm going to show you one way first of all, but essentially they boil down to the same method, but I want to stress on the two routes, one of the two routes that you can take. The first one is to check to see if the equation is in the general form. Now, the general form of the equation is y equals mx plus c. So this is the first route that we want to take to solve this. And remember, in order for us to sketch the graph of a linear equation, once we know where the line, these equations are linear because they're going to generate straight line graphs. And once we know where the line cuts each of the axes, then we can easily make the sketch. So the objective is trying to figure out where this line is going to cut the x-axis and where it's going to cut the y-axis. Once we know that, then we're good to go. So in this first method here, so we want to check to see if the equation is in the form y equals mx plus c. This involves the first method that we're going to be using. Always check to see if the equation is in the form y equals mx plus c. If it is not, you can rearrange. So that's the focus here, and you can clearly see that this equation is in the general form. So what that means is, therefore, the gradient is -5, and this would give us a very good idea of how this line would be falling. So based on that gradient, we know that the line is going to be falling in that direction because the gradient is negative. So this gives us an idea right away of what the graph of this equation will look like based on the gradient. And that's one of the reasons why we got this rule, because we get clues as to the outcome of the graph. Now, the next thing that we know once the equation is in the general form is even more important, which is the value of c. And clearly the value of c here is +1, which tells us where the line of this equation is going to cut the y-axis. So we know that the line will cut the y-axis at +1. And that is the significance of c here. And that's one of the reasons why some persons opt to go this route in terms of checking to see if the equation is in the general form, because the gradient gives us a clue as to how the line will be falling, and c tells us half of the story in terms of c tells us where the line will cut the y-axis. So we know that the line will cut the y-axis at +1. Now what is left for us to determine is where the line is going to cut the x-axis. So let us deal with that, where the line will cut the x-axis. So determining where the line will cut the x-axis. Okay, so in order for us to determine where the line is going to cut the x-axis, we know that whenever the line touches the x-axis, the value of y is 0. Similarly, if the line touches the y-axis, the value of x is 0. So whichever axis is intersected, the other variable is going to be 0 at that point, and we proved that in the previous class. All right, so the equation is this, and whenever the line cuts the x-axis, the value of y is going to be 0. Very simple. So again, when the line cuts the x-axis, we know that y is going to be equal to 0. So if we look at the equation y equals -5x plus 1, we know that when the line cuts the x-axis, y is going to be 0. So we simply substitute 0 for y here, and then afterwards just solve for x. And then we will be able to figure out where the line cuts the x-axis. So we're just going to carry over the negative term, which is -5, is come over here, it's going to become +5x. And then of course, x is going to be equal to 1 divided by 5, or 1/5, or as a decimal, it's 0.2. So we essentially know where the line now cuts the x-axis. So therefore, the line cuts the x-axis at positive 1/5. And once we know these two things, we can go ahead now and easily make the sketch, because we now know where the line cuts the y-axis and where the line cuts the x-axis. So we have those two pieces of information, where the line cuts the y-axis and where the line cuts the x-axis. So we can go ahead now and actually make the sketch of this equation, which is very simple. So the sketch of the graph is the focus, and what you're simply going to be doing is establishing our axes, and ensure always that you label your axes, because if you don't label your axes, they won't know how to turn the paper. So you just go ahead and label the axes. So we have the x-axis, which is always a horizontal axis, and the y-axis. Now we know that the line cuts the y-axis at positive 1. So positive 1 will be up here somewhere. All right, we're just making an intelligent estimate here. You don't have to be precise. Obviously positive 1 is going to be up there, and the line cuts the x-axis at positive 1/5. So we're simply going to just connect those 2 points and just extend the line past the points, because really and truly it's a line that we're drawing at the line segment, as we discussed in the previous lesson. So we're just going to extend that line right through the 2 points, and then afterwards we're simply just going to put on the values. So 1/5 there. Very straightforward. And of course, it is consistent with what we said about how the line will be falling in that orientation, which is what we got here. And that is the significance of doing it in this way, where we have the gradient highlighted, which tells us how the line is going to be falling, and also what the value of C is. Now, quickly, the next method is even simpler, and it's going to bear fruit whenever we have equations that are not in the form. So I'm just going to focus on this second method straight away. So the second method is going to be very quick in terms of how we determine these two values here that we need to sketch the graph. So remember, the equation is y equals minus 5x plus 1. Now, where does the line cut the y-axis? Now, already we know it cuts the y-axis because the equation is beautifully put in the form which resembles the general form. So that is a given already. But remember, when the line cuts the y-axis, the value of x is 0. So if we plug in 0 where x is, you're going to clearly see that y is equal to positive 1. And that is what we have here. And also, this is half of the problem. So next thing we need to figure out is, where does the line cut the x-axis? And remember, when the line cuts the x-axis, let me just write back the equation here so it stands out. When the line cuts the x-axis, the value of y is 0. So we put 0 there and simply solve for x to determine where the line is going to cut the x-axis. Carry that over, it becomes positive. And of course, x equals 1/5. And therefore, we would have the 2 pieces of information that we need to be able to sketch the graph. So this is the second method, which is pretty quick. And this method is useful whenever the equation is not in the general form, and we can go ahead and determine where the line cuts both axes. So whichever method you're comfortable with, you'll find this method useful whenever the equation is not in this form, when you want a quick determination of the 2 intercepts, and then you can go ahead and make the sketch. So this should have been the answer to the first question. All right, so I hope you guys found this video insightful, and I'll see you guys on the next video.